Okay, AC, CC, or D. So I'm going to go do the AST first. It's got almost the same in the numerator and denominator, and that's got subtraction. I'm not sure if it's decreasing. Oh, I know. I'm going to go right to the limit. It's not decreasing. It's not likely that this limit will be equal to 0. So again, highest powers, n squared over 4n squared, I get 1/4. Oh my goodness, that doesn't equal 0, so what do I know? I know that this diverges by T4D. So when the terms are not decreasing in AST, this limit will probably not equal 0. And remember, you never say diverge by AST. You never say that, right? Because that's not true. You get a divergence by T4D. Okay, so let's look at this one. Kind of talked about this a while ago. This is a really different one. So cosine of 3n, cosine function goes up and down like this, right? So this is not positive and it's not alternating. So in order to find out whether it's absolutely convergent, conditionally, or divergent, I have one thing that I can do, one direction. I must check the absolute value right away. Okay, so you have to say check and then keep the absolute value bars on the cosine. This denominator is positive because I know my n's are positive, right? It's only the cosine that could be changing sign in kind of a random fashion as n's move along. Okay, keep the absolute value bars. Now, because it's positive, right? Now it's positive. Now I can go do a basic comparison test. So I know that this is going to be smaller than or equal to 1. Let's divide both sides by 3 to the n plus 2. I still can't do anything with this. This is not geometric, but I can take this 2 off. And I can say that that's smaller than 1 over 3 to the n. So now what I have is I have 1 over 3 to the n, or you can think of this as 1/3 to the n, both the same, right? This is a convergent geometric sum because I can see the r is 1/3. Is that good for my basic comparison test? Yes, it is. So because that's convergent, I'm still in the little there for us, right? This one, really important that you keep the absolute value bars here, right? So now I'm saying this converges by basic comparison test, right? Big emphasis, sorry, I got so messy. Big emphasis that you have to have the absolute value bars there. So what do I have? I just found that the absolute value converges. Oh, therefore, the original guy is AC. If the absolute value converges, the whole thing is absolutely convergent. Okay, so when there's a sign, you have to be careful in thinking about it, right? That this is not positive and not alternating. So let's look at this one. Sine of n pi over 6. So sine will look up and down, it'll move, and if I plug in different n values, it's not going to be positive and it's not going to be alternating. So there's one way to do this. So you must say, I'm going to check the absolute value. So you have to keep the absolute values on the trig function. And the n's do not need absolute values because they're going from 1 to infinity, right? Okay, so you take the absolute value, and really the only thing you can do is a basic comparison test because I need to get rid of the sign in order to compare it with something, right? So I know that's smaller than 1. So I'm going to put my denominator in. Still can't do a p-test on that. But I can say, let's take this off, right? I'm allowed to take the smaller term off, even if it has n's in it. I can say that's smaller than 1 over n squared, because this has more on the denominator. Now I know this converges by p-test. So what do I get as a conclusion? Since this converges, I know that this one converges. So little therefore with the absolute value bars, right? Whoops. N pi over 6 n squared plus 2n. This converges by the basic comparison test. I just showed that the absolute value converges. Therefore, this is absolutely convergent.